ألف سلامة عليك.
Thank you for attending the last session for the cryptography course. Today, we will cover the last topics in our training course. I think we need some refreshment for our information for the last two sessions, where we spoke about the cryptography basics and concepts, and the most important information which I want you to remember, that we mentioned that the cryptography depends upon the algorithm and the key secrecy. And the algorithm, it's common. All people know the algorithm, they know how it is working, and there is nothing considered as a secret in the algorithm. Then the only secret which is considered is the key itself. And the key, as we clarified, it will define how the algorithm it will be used, and what are the mathematical operations which it will be applied for the clear text to be changed or to be translated into cipher text. Also, we discussed some important concepts about symmetric and asymmetric algorithms, and we explained that the symmetric algorithms, they are considering or using the same key for the encryption and decryption process, and usually this key it's called the secret key. And in some other situations, it can be called as a session key. And this session key, this is the key which is created only for one session. This means that if you have two hosts are connected together and they want to send the encrypted data to each other, and after they send the data, they disconnect the connectivity between both of them, then another connection, it's opened between the same two hosts. Again, a new session key, it will be generated. Then we discussed the asymmetric algorithm, and we mentioned that the asymmetric algorithm, it uses two key, one for public, one for encryption and one for decryption, and these two keys are mathematically related to each other. In other words, if one of these keys it's used to encrypt the data, it will be the same as the the other data, it will be or the other key, it will be used for decrypt the data. And usually we are calling these two keys which are using in the asymmetric as public keys, public and private keys. Then we discussed the cipher and the stream block and stream ciphers. The block cipher, this is the cipher which is used for encrypting the information in the form of blocks. This means that the clear text data, it's what we can say divided into blocks. When these blocks, it will go through the encryption process. But in the streaming, it will be totally different, because it will make the encryption bit by bit. And usually the streaming, it's using the key generator and uses more power. And this is the reason why we are saying the stream cipher, it will be implemented in hardware, and it will be better to be used on hardware infrastructure rather than the software. We discussed also the some of the algorithms of the symmetric algorithm, symmetric cipher, as the DES, 3DES, AES, IDEA, Bluefish. All these are algorithms which are used under the symmetric algorithms. Usually we are using the AES, and as we saw before that, you will find these algorithms uses different block type, block size or key size. And of course, we explained that these key size and key blocks are changed, and the values is not standard as in the disk, for example, because now people who are developing these algorithms, we are not caring only about the desktops and servers. Now we have in their consideration the IoT, tablets, smartphones, and so on. Then this means that if we have a key for 2K, for example, it will be great on a server. But if you want to have the same algorithm with the 2K encryption on a mobile, this it can be a crisis for the performance, and it will not provide any good performance. This means that it's not recommended. Then we can minimize the key length into 1K or maybe 512 or whatever, any size which it will be acceptable for the performance. These are the major points which we covered during the last two sessions, and now I will share my desktop and we can start the other topic. But just for your to remind you, of course, if you have any question, you can stop me at any time. You are most welcome with all your questions, or you can post your question in the chat. I will regularly check the chat and answer all your questions. Okay, I think today we will start with the asymmetric systems, and we will cover some of the algorithms uses in the asymmetric systems. In the symmetric cryptography systems, we had some problems. We mentioned that the symmetric, it will provide the confidentiality only. And of course, we can understand how it will provide confidentiality. It will encrypt the data. Then no one he will be able to read it except if the person has the key. Then this means that it will provide confidentiality, but it will not provide any authentication or non-repudiation. I will not be able to ensure that this is the person which it came the message from him, or I will not be able to prove that this message is come from a specific person. In symmetric key, I will not be able to do this because the key which we have it is not related to the person. It is related to the cryptography operation. Then if I want to make a cryptography then or encryption for data, I have a secret key, I can share it with anyone, and this key, it is related to the cryptography process itself. It's not related to the person, it is related to the cryptography process itself. Also, we explained that it's not scalable because if you the number of the keys which you can have, if you can still remember the law, that it is n-1/2, and n it is the number of the users who are exchange encrypted data. By increasing the number, this means that the number of the keys which you have to keep it's increasing, and this means that it will not be easy to keep all this secret data safe. And by increasing the number of users, the keys it will be increased, and this it will be considered as heavy operation tasks, and it can affect the security as well. Also, key distribution, it is one of the main problems. Key distribution, one of the main problems, because if I have a key, I have to share it with the user who I want to exchange the encrypted data with him. And of course, as you know, that this it should happen on out of band infrastructure. I will not be able to send it by email or load it on a cloud or whatever. When this means that I have to deliver it maybe by hand or with a messenger or whatever. And these are the problems which we face during the usage of the symmetric key cryptography. The question which you may ask yourself about, if we have all these problems, why do we still need the symmetric key cryptography? Then let's drop this symmetric cipher or symmetric algorithms, because it has a lot of problems. Unfortunately, we will not be able to drop it because the symmetric key cryptography, it's very fast. It is very fast. And you know that in encryption, we need to have an high performance and fast operation, because this, it will affect the performance as well. Then we will not be able to drop it, although we have all these problems, but we will not be able to drop it. But we will act smart and we will try to utilize the symmetric with the asymmetric. Okay, there is a technique called a Diffie-Hellman algorithm session. Do you remember, my friends, when we said that there is something called secret key? And this secret key, it is the key which it is shared key used for symmetric encryption. And I told you there is another key which is called session key. What is the session key? Session key, this is the key similar to the secret key, but this, it will be valid only for one session. Valid only for one session. And I told you, forget about how this will be generated, because this will be covered later. Now we will cover how you can create the session key. The session key, it will be created uses the Diffie-Hellman algorithm. It will be created by the Diffie-Hellman algorithm. How can we be created? Let's go through it step by step. We have two users, Tanya and Erika. They want to communicate over encrypted channel. Okay, that's fine. They generate a public and a private key pair and exchange public keys. Fair enough. Then now we have a public key for, we have now Tanya, and we have here Erika. First of all, each one of them should have a public key and a private key. Then this, it will have a public key and it should have a private key. And this for Tanya, and this private key for Tanya. Okay. And also Erika, she have a public key and she have a private key as well. And this, it is for Erika, and this is for Erika as well. Great. We don't have any problem, because as we agreed, now we are using the asymmetric. Now we are using the asymmetric algorithms. If we are using asymmetric algorithms, then the asymmetric algorithm, it will use the public key and the private key. You have to create a public key and a private key for each one of them. And now Tanya, she has a public key and a private key. Erika, she has a public key and a private key. Great. Then they will exchange the public key. Then this means that now with Tanya, she will have the public key for herself, private key for herself, and the public key, and she will have the public key for Erika. She will have the public key for Erika. And Erika, she will have the public key for Tanya. I think this makes sense. We don't have any problem. Each one of them have the public and private key for herself and the public key for the other. And we mentioned that the public key, if it's open, anyone he can exchange, anyone he can have it, and so on. Okay, then let's check the second step. Tanya software would take her private key. Note here, please take care about the type of the keys. Tanya, she will take the private key, her private key. Then Tanya here, she will take her private key of Tanya, and what? And Erika public key, and Erika public key of Erika. Okay, and it will do what? And put them through Diffie-Hellman algorithm. Then she will use the Diffie-Hellman algorithm to create what? This, by using the algorithm Diffie-Hellman algorithm by using the private key of Tanya and private public key of Erica, she will create the session key. She will create a session key. This is the key which it will be valid only for one session. Okay, this who will do this step? This step it will be done by Tanya software. Okay, now Erica, what she will do? Erica, it will do the same step. It will take her private key, then this it will be the private key of Erica, plus the public key of what? Of Tanya. It will take the private key of Erica and the public key of Tanya, and it will make the Diffie-Hellman algorithm. Again, it will get the session key. Do you think the session key in both cases it will be the same or not? Of course, it must be the same because if it's not the same, then this means that it will not work. It should be the same because if it's not the same, it will not work for encryption and decryption. Okay, that's fine. Then now we create the session key. Through this process, Tanya and Erica drive the same shared value, which is used to create instance symmetric keys. This it will consider the process of the session key. This is the way for creating the session key. I know that this is very important, so I will repeat this process again. It is very important to understand how it's working. Although it is very simple, but in some situation it may confuse. Okay, step number one. Tanya and Erica, we are two users and we want to exchange encrypted data. We don't have any secret keys, but we want to use the asymmetric key. We want to use asymmetric algorithm or asymmetric algorithm. Okay, now we want to use asymmetric algorithm. We agree that in the asymmetric algorithm, it is great in the key management. And each one of them, they have a private key and public key, but unfortunately, it is very slow in the encryption process. And on the other hand, the symmetric key, it is very bad in the key management, but it is really fast in the encryption and decryption. Then we will try to merge both algorithms in the process of the encryption. How we can do it? In step number two, each one, or each user, Tanya and Erica, we will create a public and a private key. For Tanya, the public key, it will be public key and private key, for Erica, public key and private key. When we will exchange the public key together, where Tanya, it will go the public key, and Erica, it will get the public key of Tanya. And the Tanya, it will take her private key and the public key of Erica, and it will go through the Diffie-Hellman algorithm, and it will create the session key. Also, the Erica, it will take the private key of herself and the public key of Tanya through the Diffie-Hellman algorithm to create the session key. This is the session key which it will be used for encryption the data. But now, although we start with the asymmetric where each one have a private and public key, but we use the public and the private key to create a session key. As you can see that here we are using the asymmetric, and here we will use the symmetric algorithm for the encryption by using session key. Then the Diffie-Hellman algorithm, it will enable two systems to generate a symmetric key. It will allow two users to generate a symmetric key, and this symmetric key, it can be used for the encryption of the data. And why do we need this process? We need this process because, as we mentioned, that the symmetric algorithms is very fast. It is very fast. Then, as recap, we are using asymmetric key for key management, for authentication, for non-repudiation. But for encryption, we will use the symmetric algorithms. For encryption, we will use symmetric algorithms. What is the problem with the Diffie-Hellman algorithm? The original Diffie-Hellman algorithm is vulnerable to man-in-the-middle attack. Man-in-the-middle attack, as you can see here, that there may be a user, a hacker who is Lance, and Lance, he is communicating with Tanya and Erica. Both of them, they are thinking that we are communicating direct, but actually it is not the scenario where Tanya is sending to Lance and Lance is sending to Erica. When each one of them, we don't, does not know that there is a hacker in between, and they will freelance, he will collect all the keys, S1 and S2. This is why, because there is no authentication occurs before public key exchange. This is one of the vulnerability of the Diffie-Hellman. But how we can solve it? That we have to enable the authentication. We have to enable the authentication. Then this means that if we are enabling the authentication between the two users before sending any keys, then this means that no one he will be able to represent a man in the middle attack. Okay, RSA. RSA, this is the algorithm of the asymmetric encryption. This is an algorithm of symmetric encryption, and it's the most popular algorithm for the asymmetric encryption. RSA is a public key algorithm because it uses public and private keys. It is used for digital signatures, key exchange, encryption. Encryption, now we can understand the encryption. Key exchange, how we can exchange the keys, and we can understand it. But the digital signature, leave it for some time, because this it will be covered in the next few slides, and it is very important, and we will explain it in more detail. Okay, the RSA has been commonly used with symmetric algorithm, DES and AES, when the symmetric encrypt the symmetric keys. As I mentioned, that we are using the symmetric and asymmetric together. When the RSA, it will be as asymmetric. It will be used for key exchange, for authentication, but for the encryption process, it will be used by the AES, and this it will be created through the Diffie-Hellman, which it will be used to create the session key. The session key. Then, as a recap, to avoid any confusing, we have symmetric and asymmetric. Symmetric, it will be used for encryption by creation the session key, and this session key it will be created by Diffie-Hellman, and all the other processes as non-repudiation, authentication, it will be done by the asymmetric algorithm. It can be RSA or whatever, any other technique. Gamal, again, this is another protocol used, or sorry, algorithm used for asymmetric. It is not a well-known protocol, and one of the main problems is the performance. This is the reason why you did not hear about it, the performance. It's not like the RSA. RSA, it is a well-known protocol, but Gamal, it is not, because it is facing problem in the performance. The ACC, again, it is one of the asymmetric algorithms, and it is very efficient as the RSA, and it provides digital signature, key distribution, encryption. If you will have a look on the ECC or RSA or whatever, any asymmetric algorithm, you will find the same features: digital signature, key distribution, encryption, and so on. The ECC, it has advantage over the RSA. What is this advantage? That it uses a smaller percentage of the resources. This means that it requires less resources than the RSA. This is the reason why the ACC it is used with multiple devices. And when we say multiple devices here, usually we mean the tablets and the smartphones. Tablets and smartphones. When the ACC, it will be used with the tablet and smartphones because it requires less resources than the RSA. ACC, it provides the same key size for encryption as the RSA. It provides the same key size for the RSA, and this is the reason why both of them are well recognized. Although ACC it's better because it requires less resources than the devices which it can be used. The ACC are more than the devices which it can require the RSA. Okay, now we will start a new topic for the one-way function. New topic for the one-way function. What is one-way function? One-way function, this is very important mathematical concepts, my friend, and you will see that it is considered as the basic or the foundation of the integrity and the hashing. Integrity and the hashing. What is one-way function? One-way function is a mathematical function that it is easy to be computed in one direction and it cannot be reversed. This means that I can have whatever any function, I can calculate it, and this it will be the result. I cannot refer it to its original format. For example, 1 plus 1 equal 2. And this means that I can calculate 1 plus 1 equal 2, but I cannot revert it in a reverse direction because I can have 0 plus 2 equal 2. It can be 0.1 plus 1.9, or it can be 0.15 plus 1.85. I have an infinite options which it can represent. Then it is very simple to consider that the one-way function, it is a process where it can calculate a function, but it cannot be reversed in other direction. This is very important to understand because this it will be used in the messages integrity, and this which we will cover in the next module, message integrity. In the message integrity, you will have the concept of the one-way hash. One-way hash. What is one-way hash? One-way hash, it's a function. It's a mathematical function that takes a variable length string. It will take a message. It will take a clear text message, and it will produce a fixed length value called a hash. This means that you have a message. This message, it is whatever the length of it, whatever the length, it will create something called a hash. What is this hash? It is a fixed length hash, and this it will represent a specific value related to the original message. This hash, it depends upon the hash algorithm. The hash size depends upon the hash algorithm. We may have 160 byte, we may have 256 byte, we may have 128 byte. It depends upon the hash algorithm, as we will see later. What we have to understand now that we want hash value, this is the mathematical function that it will take a message, whatever the size of this message, and it will create a fixed length hash value. Specific value, it has a fixed length. Okay, let's take a scenario to understand the one-way hash. We have Kevin is a user. He wants to send a message to Maureen. Okay, he wants to send a message to Maureen. When Kevin, he calculates a hash value for the message and append it to the message itself. What do you mean? Here I have this message. This is the message which Kevin want to send to Maureen. Okay, that's fine. He will create here, he will create a hash. He will create a hash. How he will create it? He will use a hash function. He will use a hash function to create a hash. Okay, what is the benefit? We will take it step by step. Don't jump. Okay, then he will create a hash. And he will take this message which he want to send, which message, hello, how are you, Kevin? And this hash, as I told you, this hash, it represents the message. This hash represents the message because it is developed from the message. When Maureen receives the message, she performs the same hash function given used okay, then she will receive this message and the hash. Then Maureen, it will take the message and it will create another hash. It will use the same hash function and it will create another hash. Let's call it hash 1. Okay, then Kevin, he create hash and Maureen create hash 1 because it received the same message which Kevin sent. And Kevin, he used the message and he create this hash from the message. Then Maureen, it will use the received message and create another hash value, which we call it hash 1. Okay, excellent. Then she compare the result of the hash value. She will compare H with H1. H is the hash value created by Kevin, and H1 is the hash value created by Maureen. Then if both of them are the same, this means that the message it's not changed. If it's the same, then the message it's not changed, because if the message it is changed during sending the message from Kevin to Maureen, then the hash which it will be developed, it will not be the same. If the message is changed, then this means that the hash it will be changed as well. But if both messages or both hashes are the same, this means that the message it's not changed. Then this means that now we are sure that the message it's not changed, and this is the basic or the seed for integrity. You remember what is integrity? Integrity that data it should be changed by authorized users. In some situation, if you are sending a message from given to Maureen, if there is any hacker, he can change the message and send it to Maureen when the message is changed. Or there may be some problems with the digital infrastructure, and the message it will be corrupted and it will reach Maureen corrupted or destroyed. And this means that when Maureen it will create the hash and compare it to the hash which it is sent by Kevin, if the two hashes are the same, this means that we don't have any problem. The message which it was sent by Kevin received as is by Maureen. Okay, excellent. We will have another concept here. It's called Message Authentication Code, MAC. What is MAC? MAC is an authentication scheme derived by applying a secret key to a message in some form. Okay. Usually, I don't like these definitions when we are starting to understand. But let me ask you one problem, my friends. Let me ask you one question here, my friend, and I really appreciate your concentration, because this question, it will make the next few slides very, very easy. Now we have Kevin, he wants to send data to Maureen. Okay. What will happen if I have a hacker, I have a hacker here. If I have a hacker here in between, can he change the data without Morin feel that the data is changed? Again, I will explain the scenario and my question. The scenario is, we know that we have Kevin, he want to send Morin data, and we have a hacker here in between. Can the hacker change the data? Can the hacker change the message which Kevin want to send to Morin without Morin feeling that the message it is changed? I will give you 3 minutes to think, then we will start to receive the answers. Please write your answers in the chat, and we will take these 3 minutes. If you want to work together over the chat, you are most welcome. I don't have any problem. But this is very important. I want you to think about it, because it will make the next few slides very easy. Okay, I will pause the recording for 3 minutes, and I will come back after 3 minutes. Okay, my friends. I see one input from Mahendra. Yes, hacker will change the message as well as change the hash value. New hash value will be calculated with the new message and the identified guest hashing function. I did not get the message because I'm not starting from beginning. Okay, you will understand rigidity with us. Right. I think Mandra, he answered the question correctly, and I will explain it here in more details. Hackers, yes, we can make any changes, and the receiver, he will not feel anything. Why? Let's say here, Kevin, he have the message. This is the message. And this is the hash which he want to send to the Morin. But the hacker here in between, he will receive this, and he will make the message, change the message into M1, not M. He will make some changes in M1. And he will calculate another hash for the hacker. This, it will be another hash for the hacker. And he will send this to Morin. Morin now, she will receive this information. It will receive what? It will receive M1, not M, which Kevin sent. She will calculate a hash. The hash which is calculated, let's say it's hash 2. And it will create with the hash which it received. It received hash C, which is sent by the hacker. And when they compare together, they will be equal, because the message is M1 and here M1. Then this means that the hacker was able to change the message, create new hash, and send it to the sender, receiver. Then in this case, the receiver, he will not be able to detect that there are some changes happened on the message which it was sent originally from the sender. This is the method where we want the MAC function to be used to solve this problem. We have multiple methods, HMAC, CBC MAC, CMAC, and so on. Look here, my friends, what will happen? Here, this is the hashing process. Now you have hashing, you have a message. This is the message, which you call it the M, and this is the message digest with the hash, and they will integrate it together into one specific message and message digest. It will be sent to the sender, it will be sent to the center, and the center, he will calculate the message digest again and compare it with the one which he received. This is the normal hashing which we explained before. We don't have anything different here. Okay, look here how the HMAC it will work. Now we agreed that we have a message and message digest. These are equal. Message and message digest. These are created from the sender. He will use a secret key. When we have another factor, it will be integrated here, the secret key. And the secret key, it will be used with the hashing algorithm to create a specific MAC value. The secret key, it will be used with hashing algorithm to create a MAC value. Then the message, it will not send with message digest as before. No, it will create with a MAC value. What is the MAC value? The MAC value is the message digest plus the secret key. Then now we have a secret key, and this it will be sent to the user. This means that now the hacker, he will not be able to play with it. Why? Because if the hacker play with the value, he does not have the secret key. He will not have the secret key because the secret key, it is not used to encrypt the message digest. If you will not be able to encrypt the message digest, then this means that the receiver, he will know that I did not receive the original message. Then this means that the message, it is changed, then it could be dropped. Then the difference between hashing and HMAC or HMAC, which is considered as a security, that there will be a secret key, it will be used between the sender and the receiver. It can be a secret key or it can be a public key and a private key, but by the end of the day, we need to have a key for authentication and to make sure that this key, it cannot be shared with the hacker where he can make any changes for the message and private and create a new message digest. We have a question here from Mahendra in the chat. I don't see center using or uses the message digest in. No, we are using the message digest, but message digest, it will go with the secret key through the hash algorithm. It will go through the hash algorithm. It will, this hash algorithm, you have the message algorithm plus the message digest. Message digest and secret key, it will go through hash algorithm to create the MAC value, and then the MAC value, it will be integrated with the message. Mahendra, okay, I got it. Okay, excellent, great. And this is the difference between the hashing and the HMAC. And the only thing which I want to tell you here, my friends, this is the way which we are protecting against the unauthorized changes, the integrity. It is used for integrity, data integrity. Okay, then what are the hashing algorithms? What are the common hashing algorithms which are used? When you will hear hashing, this means that it is one-way function. It will create a message digest. This message digest can be encrypted by a secret key or private key to make sure that it is coming from a specific person. And these algorithms for hashing, we have MD5, we have SHA, we have HA1, SHA2, SHA3. MD5 and SHA, SHA1, and SHA2, they are vulnerable. It is proved to be vulnerable. Then it is recommended to use the SHA3. We will go through all of them. MD5, it produces a hash of 128-bit hash. And it proved that it is vulnerable for collision attacks. It is vulnerable. Collision attacks, what is collision attack? If a hash algorithm takes steps to ensure it does not create the same value for two or more messages. This means that if we have two different messages, and we create the same hash for two different messages, this is called collision free. It's said to be collision free. Anyway, this is not an issue. Let's say that it is vulnerable and it is not used anymore. Okay, then we have SHA. Again, SHA, it will create 160-bit hash value, and again, it is vulnerable, and it's common to use the SHA2 and SHA3. And this is a summary for the hash. The MD5 produce 128-bit, SHA 160-bit, and you have SHA 1, 2, 5, 6, 3, 8, 4, 5, 12. This number, usually it will be the hash value. This number, it is the hash value. Okay. What are the attacks against the one-way hash function? We have collision and birthday attack. Collision, we discussed the collision, that the algorithm produces the same value for two different messages. We have two different messages, and it has the same hash value for both of them. This is considered as a collision attack. This is considered as collision attack. Birthday attack, this is something different, and it depends upon a specific concept. I will go through it step by step with you. It is easy to find two matching values in a sea of values than to find a match or just one specific value. This means that if you have large number of values here, we have a huge number of values, it is very easy to find two values or two matched values than to find a specific one value. For example, I have here, I want to say, okay, I want two equal values. Okay, any two equal values, but if I want to go to this huge number of values and I will say that I want to find this number, it may be difficult and it may be impossible, it not be there. But if I'm saying that I want to find two specific values, equal values, then the possibility it will be easier. If the attacker find a message with a specific hash value, then here we have a message, and it has a hash value. It's equivalent to find someone with a specific birthday. This is the reason why it's coming birthday attack. Then, if the hacker was able to find a message with a specific hash value, it is equivalent to find someone a specific birthday. I want a specific birthday. As I mentioned, I want a specific value here. This is not easy. And it's not easy also to find a message with a specific hash by a hacker. Okay, then what is the easier? If he finds, the attacker, find two messages with the same hash value, when it's two messages with the same hash value, it is equivalent to the collision attack. It is equivalent to finding two people with the same birthday. It is equivalent to find the two people with the same birthday. And this is a concept of the birthday attack, not only in the cryptography, but it is in general as a mathematical. That if the hacker is searching for a message and a specific hash value, it will not be easy, it's difficult. But if he finds two messages with one same hash, we have the same hash value, it's equivalent to finding two people with the same birthday. Right. How it will be attacked? Two messages that hash to the same value would require a review of only 2 to the power 2 to the power n over 2. It can be written in this format. 2 What do you mean? Now, if I find one message with specific value, I can work number of X times till I can discover the message. Okay, but if I have 2 messages with one hash value, this means that the number of times which I have to utilize to understand the attack type or the messages, it will be 2 to the power n over 2. Here, it will be 2 to the power n. Here, it will be 2 to the power 2 over n over 2. An algorithm that is 160-bit like SH1 may require approximately 280 computation to break. Of course, the n, it is the number of bits of the message. N is the number of bits of the message. This is the concept of the birthday attack. A hashing algorithm. I think it's not clear. Let me clear this space. Hashing algorithm that has larger bit output is less vulnerable to brute force attacks such as birthday attack. Of course, if you have 160, it will be good, but if you have 256, it will be better. If you have 512, it will be better, and so on. And as we clarified before, the number of bits, it will be increased in the new algorithms. Okay, I think we finished the message integrity and we have to start the public key infrastructure. The public key infrastructure, it's an important module and I think we deserve a break.